So normally I try to record everything, and that way you guys have a copy of it. And last week, I was gone a day, which some of you already heard the horrible wisdom tooth story. Don't have them. If you haven't already gotten your wisdom tooth, just hope they don't come in. If they do, hope they come out really easily. How about that? So, dentists are horrible, horrible people. That's all I'll say. Now, my dentist is really nice, and he's apologizing the whole time. So, what we want to do is look at what's best practices. What are we doing in buildings now? So, almost no matter your job, when you get out of here, you are probably going to have a network you are going to have to deal with at some point. So you're going to graduate, and you're going to be in an office, and they're going to have a computer or some other device, and they're going to be networked together. Oh, man. So somehow we're going to have to deal with this. And you guys are the young, the technology savvy. You guys are the people that business is going to go to and say, hey, we need to figure out what we can do with our network. How do we make it better? How do we make it stronger? How do we make it more robust? And holy crap, it broke. What do we do to fix that? And so we're going to talk about some of these pieces that are going to happen in a typical business. What kind of things we have in a typical business. And so we showed those students here on campus, we showed our lab here, but some of you have already seen it. And there's a lot of different organizations, and we've already looked at, there's all these different groups having standards, and it almost makes it a little confusing sometimes because we have the IEEE, the Engineering Society. In this case, a lot of this commercial building wiring is something called TIA, EIA, whatever. Normally we abbreviate it, and we just say, okay, it's 568. And we say, if you ever hear the term 568, that refers to commercial building wiring. And we're going to have a lot of references to that nomenclature. And so there is a whole documents built, and it's continually revised. People go, what are my new best practices? Now we've got 10 gig Ethernet or 40 gig or 100 gig Ethernet. How do we deal with that? What are the new requirements? And so these are the standards that companies will come up with. Well, you hire a company and they give you a standard, and they may also reference some other things. And so one of them I see a lot is something called BICSA. And so you'll see there's another, it's a building like trades group. So it'd be like Home Depot and Menards and Lowe's all got together and said, hey, we have this organization and we want to come up with some standards. And so it really sets kind of inside of this and says, here's what our standards are. And usually, and not always, but sometimes these other standards push things that are better for the installers. Because they say, well, we want it to be certified to our level, which sometimes can cost you additional money. So what we're going to talk about is all based on 568. And if you decide you're going to go take the Network Plus test, and this is not a bad network or a bad test to take if you want to get some certificates, the Network Plus test will let you in the door in a lot of jobs. So that 568 is where this test is really based upon those standards and those pieces. And so there's a lot of references to what we're going to look at. So we want to look at a typical business and some of the nomenclature that you're going to run into. And so this is a typical business. So if you imagine this as your offices you work in or here at Peru State College, some of these same things that are on this slide we see all the time. So at your house, you have a DMARC. So at the back of your house, if you go around back and you have Windstream or you have Time Warner Cable or you have all kinds of different other people, you have a box on your wall. And if you really look at it, a lot of them even say DMARC point or demarcation line. And that's where the phone company or your internet service provider or your cable company stops ownership and you begin ownership. It's that entrance point into your facility. And so look at your house. Look at somebody else's house. Don't go snooping around everybody's neighbor's house. But if you look, you're going to find those. And a lot of times those boxes are really clever because they will have one side you can open and another side that only the phone company or Time Warner Cable or somebody else can open. So one side will be openable, one side will have a key or something. We can also look at where you can get keys for all of those, but we don't really want to get into that yet. So that's our demarcation. That's where thing comes in, our Ethernet comes in. So at our house, in my particular case, I actually have a demarcation point in my house where there's fiber that's in the ground outside, there's a pedestal in the ground. It comes up out of that, comes tracing across my yard in some kind of squiggly line, and comes up into my basement, and I have a box. And that box has fiber running into it, and I have a network port out on one side. I can open the box, and I can look at the network side. I can't open, without the proper tools, I can't open the side that's got the fiber in it itself. So that makes sense. That fiber is fairly fragile. It's the size of human hair inside of its cladding. Probably better if I'm not in there with a screwdriver poking around. Generally, it also has to do with who pays. So, if anything happens to the internet connection up to that demarcation point, the phone company, internet service provider, whoever, will fix it for free usually because it's part of their system. On the other hand, if it's on the inside of my network, they'll be willing to come fix it in some cases, but are they going to charge you? Yeah. So you can think of the same way with a water line. If you have a water line going to your house, up to the meter, they fix. If it's from the meter to your house, that's that same idea. It's that line of demarcation. Here we have a data closet. So in this case, it comes into a single building. We have a data closet. And then we have, they're listed here as backbone. So it's some form of cabling that goes from what we're going to call a main distribution frame, and it goes to these intermediate distribution frames. So another little data closet. So back in our back room, that data closet, something like that, where we then have the routers and the other equipment. So that's a fairly typical setup. Here at Peru, our data comes in down in the basement of the administration building, where the servers are at, comes in there, and then there's fiber that goes in these underground old steam tunnels to every one of our buildings. Or in the case of some of the complexes, it's just buried in the ground. Very, very similar to what you're going to see on a network. Now, if you only have one building, well, then obviously you don't necessarily need to have the other outbuildings, and you may combine that main frame and the distribution frame in one spot. It depends on the layout of the building. Not all buildings are square. And we have some distance limitations on how far we can run some of this cabling. So that cable that I passed around in class to you guys, those short little pieces I cut apart, you can see it. There's a distance limitation. I can only run 100 meters. So if I came in a basement corner, I may not be able to make the farthest corners of that building by having my distribution center or that intermediate distribution center in this corner. So it may make sense to have a centralized location. Some buildings are big enough that there's multiples of those. And in fact, in this building until a couple of years ago, each floor had a distribution point. And then the building got rewired, and now it's all actually across the hallway. And again, I'm hoping that we can get in there and even take some pictures, but our computer services really doesn't like the idea of students knowing where any of their stuff is at. I may have to have you guys all sign something saying you're not going to break into the network, right? None of you would do that. I hope. So this is kind of a typical layout. So we have a few other pieces. So you're going to see these terms. So you're going to see MDF. You're going to see IDF. You're going to see that term demarcation. You may see something called horizontal and backbone wiring. So horizontal is typically from that distribution center to individual computers or individual nodes on a network, because there's a lot of other things in our network that now get connections. Think about in this building, is there anything other than a computer that gets a network connection? Anything else in this building that might get a network connection? Anything else? What's right here? No, a little further over, sorry. That does get a network connection, by the way. But, does the temperature controls get network connections in a lot of buildings? Do we have sensors? Do we have wireless access points in the ceiling? So it's not just that computer you see. You may see quite a few other locations that are all getting network connections for various reasons. So Over here, there's a network connection to this guy mounted underneath the table that distributes it out to multiple locations. You're starting to see we have this idea of something called the Internet of Things, where we're having all these ideas with sensors. Well, the more sensors we have, so you may have temperature, you may have all different kinds of things. So when we start putting in network connections, there's a ton of them out there. So that horizontal wiring is what runs into that. And so you may see all of these pieces used and maybe some more. And change slides would be really nice. Okay. So here's another example of a building, but now we're showing a kind of a 3D view. And so you're seeing all these work areas. Here's my horizontal wiring. That's that wiring coming out of that distribution. Here we have, and here they got all fancy. They called it a vertical cross connect. Well, it's really two different distribution frames, and they're mounted together. So you're going to see a lot of these terms. And sometimes we throw out terms, quite frankly. We try to make it harder than it is. But that's what we're looking at, is how do we get from all of the points we need service and all the way back to that distribution frame. So here's another example. Here's that horizontal wiring. And here's our idea of that limitation in length. So generally this is what we do. We say from that data jack all the way back to a switch of some sort, we can go about 90 meters. Well, what's 90 meters in feet? How many of you play this game on Sunday that the Huskers don't play? I mean, that they tried to play. How far is a football field? It's about 300 feet. Well, 90 meters is about 300 feet. So think of the picture of a football field. You can go that far. But think about inside of a building. I got to go up the wall, over, down, around. So a lot of times it's not really that far. And think about this building. It's nearly as long as a football field. If we had to go up, over, down, and around, you'd find out that we don't have enough length to do that. And so, in fact, in this building, it's fairly close, some of the outboard connections from where we are in the center over here. So you guys all know where the Pepsi machine is, right? The distribution center is actually right behind that. And so we'll take a look at that, hopefully. And so that's kind of one of our distance limitations, is how far we can go. So again, another look at it. So here's our data closet, and you guys have seen now the rack. Your stuff's back there in what we call a patch panel. So what I haven't shown you yet here in the class is something called a punch down. And so we come out of the wall with all these cables, and we have to have some way to terminate all these raw cables coming out. And there can be a lot of them. So in this building, there's probably 400 to 500 cables coming out in next door. When I did a work about 5 years ago at a hospital in Falls City, if you've ever been down there are over 900 data connections in one closet alone. So I'll pass one on either side. This is what's called a punch down device. And so if you'll notice, we'll start over here with Chloe. So if you notice on the back and the front, there's 8 connectors in there. And if you look at that wiring, you'll see that it's color-coded. And so our wiring comes through the wall, and it hits that punch-down block. It's the way we terminate on that raw cable coming out of the wall. And we'll show you what a punch-down connector is. So we use those to terminate coming out of the wall. So rather than just have the cable coming out and be raw. So, and then this is our typical data closet. So we try to rack mount as much stuff as we can. We have not yet looked, and I'll bring some cable testing kits in. And so one of the other things we do after we build our cable is we have to test it. So whether it's in the wall, whether it's one we've built as a patch connector, we need to check that cable. And so we have some tools, but there's also some tips we want to do. So even wire, and I said when we had fiber, we talked about it, you can't bend fiber too much. So here's an example of some fiber. I can't tie a knot in this and pull it tight, right? It's going to break. even our wire that you had somewhere has some limitations on how tight we can bend it. And even on that wire, we can actually break the wires by pulling it too tight. We can have problems where we bundle up cables. We think, well, I'm going to make this all nice and neat like we've done here. They're all nice and neat. They're tied together. We put zip ties around them. And we can actually cause some data issues by doing that. So we'll show you some tips and techniques. Some of these are really... If we have to tell you not to lay a cable across the floor where somebody's going to trip on it, but I've seen this before happen. And in fact, if you go into the lab next door, there's cables laying across the floor right now, because that's the way they installed it next door. It was the easiest way they could do it. So a couple of other pieces you're going to see in here. So leave some slack. That's kind of a no-brainer. If I leave some extra slack in there, and then I have to move a table or a desk, or I have to re-terminate, great, I have a way to do that. But the number of places I have seen where they didn't follow that simple rule of, hey, let's have some extra cabling in there, and the amount of cost can be astronomical. I went out not too long ago. I had a company call me, and they said, we know you do some work on the side. I said, yeah, okay. Let me go see what you got going on. And they had a contractor come in, an electrical contractor, and run all their cabling. Oh, okay. And they were going to have access points for wireless on the ceiling. Okay, that works great. Thought they had put in boxes. Nope. They had just punched a hole in, pulled a cable down, and because of the way they'd stapled it in, or God knows what, I haven't really figured out yet, there was an inch of cable sticking out of the ceiling. Well, I'm pretty good. I've done this for a while, and I'm up there. There's no way I can make a cable connection in an inch space. And so we are having to rerun that, or they are making the electrical contractors rerun that, and it's kind of been a big argument, and it's several thousands of dollars they're wanting to charge for a couple of cable runs that weren't done correctly to start with. So we also generally have something called cable trays. So if you were ever to up and look at all the ceilings in here, these drop ceilings are great because we can put all kinds of stuff up there. And in fact, you can see we have a ton of stuff up there already. But cable trays are much like they sound. They're a tray up there, a raceway, that you can put cables in. So it has a place for it to go. So it's nice, neat, organized, and you can reuse and move and change things. Because if I just throw it up here on top of that ceiling, what happens when somebody moves a ceiling tile? It's going to drop down. It's not very organized. So there's all different kinds of cable management systems. So you'll have things like this on the wall, not like this normally where it's just hanging out of the ceiling. So if you look over here, because we didn't put in cable management, we just tied it to an electrical cable. The worst thing we can actually do, because that electrical cable can induce EMF, electromagnetic interference. But it sort of made it a little neat over there because we can't drill in. Those are solid rock walls, and so we have a little bit of an issue in here. So we also want to be careful. Any place that's going to have any movement, and as things temperature-wise expand, or the building shakes, or whatever it is in the room, we can actually cut through those cables because they do move a little bit. And so cutting through one cable is not bad on a network. Yeah, I lost the connection. I'll figure out how I can fix it. But what if your cable's crossing a power line and you're rubbing a hole in a power line? Can that get expensive? And very painful. So we have to be careful of the physical installation. So just a couple of other things. You want to make sure everything's labeled. And so one of the worst jobs was actually that hospital down there. We had a contractor come in and install all of the cabling in the ceiling runs for us. And it went a little crossways. They ended up not doing the finished terminations into those patch panels like you're seeing switched around. Well, imagine 900 cables coming in and trying to figure out which cable is which and where do they go to. Are they good cables? Are they bad cables? So, a couple of tips. Cabling is fairly cheap. You can order it in all different kinds of colors. So we typically change colors based on its need. So we may use blue for communications, phone lines. We may use orange for emergency lines. So maybe something like a nurse call system or a fire alarm system may have a different color code. But here's the biggest key. Document everything and update it, because it's far more expensive to come back in after the fact and try to figure out what's going on than if you had accurate documentation. So if you had a list and a chart saying, this is everything we're going to do, excuse me, and this is where it's going, and cable 137 on this end connects to cable 222 on this end, it makes life a lot easier. At your house even, just a few cables, it's kind of nice to know. So if you've lived in your house for a while and you went to the power box and you were trying to figure out which outlet to shut off because you had to replace a light bulb that broke off or something, just those little labels, just trying to make sure. So that maintenance, that silly thing of making sure those things are maintenance is important. And you think, well, that's not my job. That's some IT company we hire. Is it? Because if I don't have that and they have to spend 4 days trying to track down that, and your network's down, you don't have any employees able to work, that could be very expensive. Whereas if you have a really nice, neat network diagram, we might be able to make life a little easier. So the best network diagrams you're going to see, if we still have, no, I don't have it in that one anymore. All right, so you want to organize those, and there's a couple of tools we use a lot. So one of them you can actually get for free while you're going to school here, and that's Visio. So we use Visio as a great tool because we can label a drawing, which is really nice. So if you notice, most of the jacks, even in here or anywhere you go, and now if I go to the doctor's office, I'm looking at that jack and I notice it's got a label. That way we can put those little labels. Those label makers are cheap, but not just the labels. We need actually that documentation that says where everything goes. But those labels are a really, really handy thing. You can also, when you have the cable out, you can get those small Sharpies and you can actually write on the cable itself, on the jacket. And so you'll be able to see where you're at. So you may come up with something like this, where you have a convention so you know that everything is done the same way. So in this case, we're using a router. It's only got 5 ports. And this way we can document off a drawing where those actually go to. So even in this building, and I'll tell a little bit on our computer services, they had a technician a couple of years ago, and he hadn't been in our system very long. And you guys haven't yet, we haven't told you what a VLAN is. But VLANs are something we set up inside of our switch, and so one port on a switch can only go to one specific spot at that point. And so the wirings are kind of all over the place in the rack next door. And he has a really good idea. And so part of this is a really good idea. He says, well, I have all these color-coded interconnection cables, and I've got some that are the right length so I can make it really neat and tidy. And I'm just going to unplug everything. And then based on the color codes I have, I'm going to replug everything in that rack in. So 2 things came out of that. One, nothing worked in this building. And luckily he did it in the summer, so it didn't impact classes at that particular point. But it should have been a fairly easy fix to go back in and take your wiring diagram and say, yep, this particular port on the switch goes to the teacher's faculty lounge, XYZ, wall jack here. But it didn't. There was no chart that actually showed that. And so it took them a couple of weeks to fix this, what was really a good-natured attempt to fix something, problem. So imagine somebody just walking in and start unplugging stuff. How are we going to fix that? It can even be to the point of really being silly if people don't understand. You think, well, I'm taking these classes. I'm a business student. I'm getting some CMIS pieces. I understand networking a little bit. But think about the person doing HVAC controls. So until this building was redone, there were some classrooms that had a strange issues. we couldn't get the temperature in some buildings to work right. And they have a computerized map, and all of these these have an IP address, and we can say, hey, this computer, this IP address at whatever it is, should be in this lab. Except that some of the people doing HVAC work in the campus didn't understand anything about IP addresses or what they were. And so if they wanted to see if a thermostat worked, they would take it out of this room, walk across to the room across the hallway, plug it in there. And so the wall controllers were not where the room was actually at. So I'm in here, sitting in this room with my tablet, going, well, I need to turn this air handler on, and it's not working. But the classroom across there could be freezing because those HVAC techs didn't understand what they were doing, that these were tied to an IP address. You couldn't just unplug it out of the wall and go plug it in across the street. And these are a little better. We used to have models that literally I could walk up, you could pop them off, and then go plug it in the other room. Handy for troubleshooting, but if you didn't understand what was going on, you would have a bit of an issue. So, IP addresses are really great. We need to have these maps. So let's talk about this rack system. So in the back you saw a rack. That one's called a 48 space rack. So there are 48 spaces from top to bottom, and that's a fairly common size for a rack like that. Those are back there are called a 19-inch. So between the spots, there's 19 inches. And so you're going to see that. Anybody in here have a home receiver? You got your theater system set up, your home receiver, all those things. Those are almost all based on that same size, that they would fit in a 19-inch rack. So we see it over and over again. All of this equipment we have in our lab based on a 19-inch system. So 48 inches tall. So one rack mount unit is a little over an inch tall. So our server back there is 5 units high. And so we plan a lot of our equipment needs based on this. So this one here, that's 2 units high. And the other one floating around is 1 unit high. So we can base all of our planning on how big these units are. So it gives us a standardized system to mount equipment. So ours isn't very impressive back here, but I'll try to get you some local pictures, and we'll hopefully get to see a little more. So these are a couple of different styles. So we have a 4-post rack in the back, and the 4-post rack you actually can tie in. There's screw holes in the front and the back because some of those servers are pretty heavy. That server we have back there is about 100 pounds. If we just mounted it to the front, it would bow down, whereas it's a shelf essentially across there. So you can see it on both sides. A lot of stuff, though, is very small and can be mounted on a 2-post rack. So your old telephone equipment, a lot of it was 2-post rack stuff. So if I'm just mounting a bunch of switches that usually aren't very heavy, I can mount them on 2-post. Otherwise, I can mount them on 4-post. The other advantage, though, this can freestand. This has to be bolted down to the floor to mount those. So it depends on the appropriate need, how much space we have. And the biggest issue we have with all of this, that's a great idea, but they get hot. Really hot, really fast. So if you've got your own computer, you've had a laptop, you can get a laptop, it's set on your lap, it's almost hot enough to burn your leg. And those are low-powered processors. We usually use much faster processors. They're running continually on those servers. So we have to have some cooling in there. So sadly, we don't really have any cooling in there. We don't run enough server load that we need it, which is good because I'm not sure who would pay for it, quite frankly. But if we had a full rack of servers in there, we would need some kind of a cooling scheme. And so there's all different kinds of them. And this is one idea. We have a hot aisle and a cold aisle, and then we alternate convection currents. There's all different kinds of cooling. There's even liquid cooling for some systems. The biggest thing when I go by Google's data centers or anybody's data centers you're going to see are the monstrous cooling towers. If you walk by the administration building and you walk down that little steep little walkway down between it and the library, those AC units that you see that are running in the middle of winter, they're cooling the air or the servers that are running our campus because they put out that much heat. And it doesn't take long to overheat. in 2009, and I probably told this story in a couple of classes, but we opened up the center, the hospital in Falls City that I was also working with. Data closet was way too small, but it had heating and cooling in the middle of winter. We opened in the middle of a snowstorm. Well, nobody had thought about how do we keep those air conditioning units from packing up with snow and ice in the winter that were up on the roof. And those air conditioning units quit. And that server closet went from 60 degrees to 140 degrees literally in half an hour. It's in the middle of the facility. Not a window to be seen, which is a security issue if we'd had one. And so we had to bring in portable air conditioning units and route cool air through there and try to keep this cool enough. Because it shut down everything from the phone system to nurse call to heart monitors and all kinds of stuff that was sitting in there. So how do we keep these things cool is actually a big issue. So sometimes we put our servers where we can get a cooling system. So one of the considerations when Google says, I'm going to build a new data center, or Facebook is going to build it, number one concern is how much do I have to pay for power? Can I get cheap power? Do I have availability to backbone fiber? And we fit those two areas. But other areas have some advantages in terms of cooling. So sometimes they want to be by a river. The reason Cooper Nuclear is out there by a river, to get cooling water to keep it cool. Same way with a lot of industrial complexes. They need to be able to cool that down. And so, again, if we look at Google Data Center, what you actually see is mostly the cooling towers trying to keep that cool. And so if it'll show up the right picture, which I went to the wrong one. So if you don't know, there's a Google Data Center. So that's what a Google Data Center looks like on the inside. Most of what you see there is really equipment running around for the cooling system. And I don't think they have. Let me see if I can get the map of it real quick. We'll do the overhead map. And if you look at it, there it is. What you actually see when you zoom in from above, and if you ever want to drive by, it's kind of interesting. All of these are cooling towers. All of these are cooling towers to support the data center in here. The majority of this building is cooling towers. And part of the reason this was built is that availability of cheap power, because Mid-American Energy is right there, provided them a cheap contract for power. And right along this highway is some of the largest capacity fiber that crisscrosses the country on. So those two things go together. But if you drive by this, if you've ever been in Council Bluffs and you drive by, all you really see, because they've got dirt berms up here, is you see this little piece, the administration area. But they have gates up and all different kinds of things. But from overhead, what you mostly see is how do we cool this monstrosity. And so if you zoom in, you can see those are all giant air conditioning cooling towers for that facility. So some places have even tried to figure out ways, in the winter, can we use that heat to then heat our facilities? And they've been mildly successful. So, and I think as we go in the future, you're going to see more and more places try to do that. Come up with a way that they can have that heat that's left over generate other uses. And so college campuses and their data centers, I think you're going to see them heating dorm rooms with them, for example. And I think you're going to see that. So one of the issues we have with all of our facilities, though, is what happens when something breaks. What do we deal with it? So if it's our own computer and it breaks, what do? Well, we can't just drop out of school because your computer broke, can you? Hit the Geek Squad, so that's an option. And you wait a week for them to fix it. But you have something in your computers, and we have a term called fault tolerance. So what kind of things can we do to continue to operate when something breaks? You guys go borrow your brother, your sister, your roommate's laptop and finish the assignment. You go to a computer lab. You do those kinds of things are your methods that you continue to operate. So I'm at my house, my laptop fails, what do? Grab another one. Luckily, my wife has one I can use. Well, that doesn't always work for that server because we don't want somebody standing there being able to switch out a server, and we want it to handle it as automatically as it can. And so we build in multiple components in there that are what we call fault tolerant. So if I have a hard drive that dies, I get a little warning message that says, hey, this hard drive is failing. You need to replace me right away. And so we will talk about that techniques, how that works. But your own computer has one hard drive. Most computers on a server side have anywhere from 5 to 20 to 70 or more hard drives that they're actually going to use. So we also do some other things where we store data not on that server, but in a dedicated device. And in this case, they call this one a NAS, Network Attached Storage. So Network Attached Storage is attached to the network system, and it's really designed only for saving files. So in here, you guys see that shared server drive. Now online, obviously, we don't get to do that, but it's useful for storing data, and it's a great place we can store data. There are tons of them you can buy even for a small business that are fairly small and fairly robust, and you can buy one pretty cheaply. So the book, I'm going to argue a little bit about their nomenclature in here. So let me explain why. So the book explains that a SAN is a storage device, and it says, okay, there's a couple different ways. There's actually a couple others that aren't listed here, and it's going to show you a SAN. So again, we like to have things that rhyme. So our file server, so here they describe a SAN as connecting using fiber, and that's true. And that SAN over here, that storage box, connects into our file storage. And notice on my computers, if they want to access that storage, they have to go through that file server, right? That's the way a SAN works. So storage attached networks, very, very fast storage. And now that we've got virtualization in most businesses, they're even more important. We store everything from the operating systems and everything on those SANs, and then you have multiple computers that are using that drive. Our book, though, I think makes a little bit of an issue. So if I go back up to the way our book describes a NAS, so our book describes a NAS, network attached storage, as also connecting directly to the file server. But I think what you're mostly going to find, especially in small businesses, is that this NAS and the file servers are all connected together into a similar switch. That is the model that you're most often going to see. Can it be done this way? Yes. But most likely what you're going to see when you see a smaller SAN or a smaller NAS is you are going to see that it connects into the switch just like the computers do, just like the switch does. And what I'm talking about are things like these QNAP devices, Buffalo storage, all these different things. So I'm just going to show you what QNAPs are, and you can see one here. So this is available even at Walmart. So this is a small NAS. This device doesn't connect directly to my server. It's going to connect out on the network. It is its own little server. This particular case, it's got space for 4 drives, right? So it would store quite a bit. We can even buy it at Walmart for $900 without any drives. So loaded up with drives, you're talking about $1,500. Most businesses can afford that, correct? So you nod your head and go, yeah, I hope. Because if they're paying you $25 an hour, we hope they can afford another $1,500. So this works, and this is what you're going to see in a lot of smaller businesses. They go, hey, we've got a server, and you go in, and what they've actually got is something like this guy running. And these are very useful. They do a lot of great things. But I just wanted to point out that our book describes it a little differently. So in our book, it's describing this NAS being connected directly to the file server. But it's really picture a switch and everything being cojoined. So they can be either direction, but you're seeing more and more commonly that idea of that NAS connecting directly to our network. All right, so I'm actually going to stop lecturing for right now. My throat is about done. We have a couple of weeks in this material, so make sure you have read the material for both weeks in here for Wednesday. The other thing I want to point out, if you will look on your discussion boards this week. So we have a couple of discussion boards, and so I am going to see which window I have that open in. So at the very top of your discussion boards, there is a new discussion board that has appeared. Some of you have already posted in that. I want you to do this. I don't need details, but I would like you to post in there. The other part I want to talk about our discussion board is there is an assignment in discussion board for week 5 and 6. And so we are actually going to book some time that we are going to do this one and record pieces of it. We're going to install something called Spiceworks. I want to show you guys a lot of really great free tools. Things like VirtualBox that you can make sandboxes. One of the greatest tools that I have ran into is something called Spiceworks. Spiceworks, if it we're buying it, and the college buys something similar to Spiceworks, they're spending about $20,000 a year. I'm going to show you the free version of that I think every business should have some version of this running, and we'll look at what it is. The other piece of that I want to talk about is that community. So don't do anything on this one yet. I want to talk about the Spiceworks community. Because I like to think I know a lot about things. But in this community, there's 20 to 30,000 hardcore geeks every day living and working and dying in that IT industry. And so I have asked questions in there, and I have gotten very, very good responses because these guys are very informative. And sometimes I'll even just do a search through there. Have you seen this before? Have we? So it's a great repository of knowledge and information on top of providing a service that's really, really good. So, there was one other thing, and I'm trying to remember what it was I wanted to make sure we got to today. I want to make sure you've read your book. Lab connections. If you are not doing the lab connections, you need to get in there and start working on them. The first couple chapters were really pretty, they were just little quizzes. They're not little quizzes anymore. Now they are actually going through some of these concepts that we're trying to work out and explain. They will take you a little bit of time to do some of them, but they are hopefully going to help you understand some of these things. So when we start talking about what a SAN is versus a NAS, what the differences are. And we try to make as many acronyms as we can in this class to confuse you and drive us all crazy. But it will also hopefully improve that. Because what I want you guys to leave with is a really good base understanding of why this stuff is important. It's the world we exist in around us. Once we get the wired piece down, so the foundation, it's a little more exciting in the next couple of weeks when we start looking at wireless, I think, in some ways. Because wireless. We have our phones, and we have all these tablets and devices. But we have to have this piece in structure before you can get to the wireless piece. All right, so I'm going to give you the rest of the class period to work on. I want to see if this is going to record.